Hello everyone, I'm João from That's Brilliant. In this video, we're going to have the sixth video on the mathematical proofs of trigonometric functions, the mathematical proofs of the derivatives of trigonometric functions. And the function of this video is going to be the cotangent of x. So this video, as I said in the last video, this video is going to be a little bit quicker because this proof is very similar to the other proofs. So I'm going to leave the links to the other videos in the description below. So in case you have any questions, you can post them below, or you can watch the other videos because I made this very similar steps in more detail in the previous videos. So let's start off the mathematical proof. The function f of x, whose derivative we want to find, is equal to the cotangent of x. So f prime of x, the derivative of this function, is what we want to find, is equal to the limit when h approaches 0. And remember the definition of a derivative. It's the limit when h approaches 0 of f of x plus h minus f of x over h. In this case, f of x is cotangent of x. So this is this limit when h approaches 0 of cotangent of x plus h minus the cotangent of x divided by h. This is equal to the limit when h approaches 0. And remember, tangent of x is sine of x over cosine of x. The cotangent is the reciprocal of that, which is the cosine of x over sine of x. So this is going to be equal to cosine of x plus h over sine of x plus h minus cosine of x over sine of x. And all of this divided by h. So let me change colors. This is equal to the limit when h approaches 0. And then we're going to calculate the least common factor between sine of x plus h and sine of x. So this is h times sine of x plus h times sine of x. And in the denominator, we are going to have sine of x times the cosine of x plus h minus the sine of x plus h times the cosine of x. And now we're going to use an equation that we study in trigonometry that gives us the sine of the sine of two angles added up. So the sine of the addition of two angles. So using mathematics, sine of a minus b. In this case, it's an addition, but it's negative b. So it's sine of a minus b, or in this case, we're going to use the equation sine of a minus b. This is equal to sine of a times cosine of b minus sine of b times cosine of a. If this sign was a positive sign, then we would have a positive sign right here. So it's just one equation we study in trigonometry that we're going to apply here. So notice that a, in this case, is x, and b is x plus h. So this is equal to the limit when h approaches 0, and then we're going to go from here to here. So this is going to be the sine, and the word I was looking for, the sine of a difference of two angles. So this is going to be the sine of x, a is x, minus b is x plus h. So x plus h. And all of this divided by h sine of x plus h times sine of x. This is equal to, changing colors again. So this is equal to the limit when h approaches 0. And now this is going to be the sine of x minus x. This is going to be x minus x minus h. So x cancels out with negative x, and then we have negative h. And all of this divided by h sine of x plus h times sine of x. Now remember that sine is an odd function, which means that the sine of negative x equals negative sine of x. So, in other words, we can bring this negative sign out of the sine function, and we can also bring this negative sign out of the limit, because this negative sign is the same thing of having a negative one multiplying here. So this is equal to, we're going to use the property of limits that says the limit of the product is the product of limits. So it's going to be equal to the sine of h over h times the limit when h approaches 0, and the limit of what we are left with. So it's 1 over sine of x plus h times sine of x. Notice, I almost forgot it, the negative sign. We have a negative sign here. So notice that this limit here is the fundamental trigonometric limit, which is equal to 1. So this limit here is 1. And I think it's good. I'm probably going to do a video proving this limit, because it's a very fun limit to prove. But yeah, if I do, this is going to be in the next video, in future video. But yeah, so this limit is 1. So this is equal to the negative sign here. And this limit, when h approaches 0, this function here approaches 1 over sine squared of x. And 1 over sine, remember, 1 over sine is cosecant. So this is equal to negative cosecant squared of x. So we have just proved the derivative ddx of cotangent of x, which is negative cosecant squared of x. Thank you very much for watching, and I will see you in the next video.